squared. Okay. So then this is the NMTC paper. This is this year only, 2022. Let us begin with the first question. So I'll just read the questions and then because I have not tried them, you guys have tried already. So you should do it, take the initiative and do it. Okay. So ABCD, this is a trapezium. AB is parallel to CD and then some sides are given. Okay, so it's the other way. Actually, it's better because then we'll have to draw these things also. Let's just do it on the board. Yeah, it's not be good. Yeah, this problem number 1. Yeah, this is 3015. This is 30. This is 15. Yes. Find the area of the trapezium. Okay. So how do we do this?
Sir, I had drawn perpendiculars from C and D to find the height.
Okay, right. So then how do you find the height?
So there's a rectangle and that is also 15 then.
Right. This is 15. Okay.
And if we take one part as A, the other will be 15 minus A. So with Pythagoras theorem, we can say 13 square minus A square is 14 square minus 15 minus A square.
Right. Others have also found the height then in that way. So what are you guys getting as the height? Ishana, have you calculated? Do you remember?
So I don't remember.
Yeah, no problem. Let's calculate the height now. Anyone has calculated the height? Then it will be faster. Otherwise, we'll just do it now. There's no problem.
I think it was 252. I don't remember.
252. Okay, let's calculate it. Yeah, 252 will be
That
our.
was the area, I think. The answer is 252.
Right. Okay. So then the height can be calculated, right? The technique is clear. This minus. Right. It's easy. So it's not even a quadratic equation, right? Okay. It's easy. Has anyone done it in a different way? Any different way? Without finding the height? Or just any different way? No? So how about we try this? This is something that I like because it's just a different technique. Okay, maybe we should just discuss a few things around the problem. It would be good, maybe. Although we had promised to go fast. Speed. And then we can use similarity. I don't know if that is very useful, but right, we can try to use similarity. So like, there is so like PDC by PAB, you know, so this is the whole area of PDC by the total area of PAB. Can anybody tell me this ratio? Can you verify? It's 1/4.
Yes.
Right? By similarity. Let us see, can we do this without the perpendicular? Yeah, so far we know this. PD and PC, can we quickly find them? Sorry. 13 plus x by x is 2, right? If this is, PD is x. 13 plus x is the whole thing, and x is half of that. So, don't have to write, right? It could just come out to be 13. So, I shouldn't even be writing it, because just logically, by common sense, it is 13, right? And this is 14. Correct me if I'm wrong. Because then only it becomes half, right? One doesn't need to do any calculations. Now we use a theorem so we use a theorem in which this work of dropping perpendicular is already done, and we have a pre-made result, and that is the Heron's formula. Am I getting the phrase correctly, right? This
Yes.
work of dropping perpendiculars is all encoded and made into a package, and that's Heron's formula, and we use that. I'm not saying it's faster; it's just fun to do it in a different way. Okay, is it fine? And use the Heron's formula to find PAB, and then just divide it by 4. Okay, not divide it by 4. Take 3/4 of that or something. You understand? Take 3/4 of that. That's your ABCD, because it's 1/4. It's a slightly different way. Nothing. Maybe.
How is it 1/4 again? PDC by PAB?
Yes. Please, someone give the explanation.
The ratio between the bases is half, so the ratio between their areas is 1/4.
Yes. Right? Ratio between the areas is 1/4. So because you see this is parallel, so PCD is similar to PBA. Nagesh, is it okay?
Yeah.
Right? Okay. And you can see that this can be used to even derive a formula for the area of the trapezium in terms of sides. I'm not saying that you should go and do it, because it's easy. You can do it, so you don't have to do it, but you can play around with that. Yeah. One more comment I would like to make is it is an interesting thing that in a trapezium, knowing the length of all the sides tells us the area. Let me say it in a different way. It is interesting that in a trapezium, knowing the length of the sides determines the area. It is not always true, right? Suppose I told you that you have a side with all 4 sides equal and equal to 1. So you have a quadrilateral in which all 4 sides are equal to 1. Tell me the area of that quadrilateral. Well, it's not possible to tell, right? There is not enough information. You could make a square that stands up straight, maximum possible area. You could also make a rhombus. Areas are, you can see they are not the same, clearly not the same, right? So if we don't know, even though you see there we know that the sides are parallel, even if you say that it's a rhombus, its still area is not determined, because only sides are parallel. It's a interesting thing is all I'm trying to say. compare the situation like this, right? Here also sides are parallel and they are all 1. You do not know the area. Here you know the area. Why is this happening? Can anybody see through this? It's not just the area. The figure actually is completely fixed once you say the 4 sides and a trapezium. But if you say 4 sides, all 4 sides and a rhombus, it's not fixed. You can say it's fixed because you can calculate and you can find out those height. You can actually find out the height. The height can be determined, right? From the geometry, from the calculations we saw, the height can be found. And clearly in a rhombus you cannot. So you can just dismiss it. You can just say that. But geometrically, do you feel why does the trapezium become rigid once the 4 sides are given? What is it about the trapezium? Or does
We
it
can
not?
find a relation between the two parallel sides once their values are given to find the height.
Right. But what the way I see your answer is you have just gone one step further in the calculation. Right. I mean, I just said the calculations will tell you, but we've gone one step further. But yeah, I'm not getting a geometric insight. The question which maybe I'm asking is like, why is the height really fixed? Do we know that geometrically? Right. And the second is, even if the height is fixed, yeah, so no, maybe that's
between a trapezium and a quadrilateral.
Sorry.
Why is the height fixed between a trapezium and a quadrilateral with the same sides? Is that what you're asking?
Yes, kind of. Yeah. Why is the height fixed? That is one key question, because from there other things can be explained.
The lines are parallel, so the distance between them will be fixed, right?
No. The lines being parallel does not imply that the distance will be fixed. That is precisely what the rhombus tells you. Not the rhombus, right? The rhombuses tell you. There's something about the trapeze. That's why it's a special kind of shape. It's a steady shape. You can kind of feel it, right? That yes, you cannot get two different trapeziums, but it is still. Or am I saying something wrong? Given, so here is clear question. Given 4 lengths is a trapezium uniquely determined. Actually, what I've been saying is incorrect, I think. Anyone? See, the problem is that a rhombus is also a trapezium. Is a trapezium.
Yes.
And when I give you four sides, when the four sides are given, it is not uniquely determined. Somehow this trapezium it was uniquely determined. What is going wrong? To analyze this, we should see the distincting feature. There are a lot of intuitive things I can say, but just to say it in an effective way, maybe to analyze it, we should consider two distincting things, which maybe somehow you're already there, it's there, but you're not getting the word to say it maybe. One is when the parallel sides are equal. When the parallel sides are equal. In this case, it is not uniquely determined because clearly, right? If there are two parallel sides, sides, and they are equal, okay? They are parallel and equal. Then the other two sides also become parallel. That is something that you can prove, okay? Then you can draw several figures with the same information, with the same side information. Yeah. In this case is a loose case, not equal. Both intuitively and even this is almost rigorous. Just draw two pictures. Yeah. Now let us. So is that case clear, everyone? You have to tell me. Okay, I will not know. Yeah. And if you don't know, then maybe just try to answer the questions. Say, then you will know if you maybe not understood. Then you will go see the problem. Okay. So try to participate. So when the two parallel sides are equal, then that case is done. And when not equal, just write the full. When parallel sides are not equal. So really what question I was asking is when the parallel sides are not equal, then it seems like we get a unique trapezium. Why is it? Why do we get a unique trapezium? Do we get unique? And why? So let's take a different example just for the sake of, or maybe we can take the same example actually. Let's say that this is 15 and this is not 15. So my point is that it's not about 30. Okay, 15 and this is 18. It looks like maybe 22. Now, if the other two lengths are given, then why is the figure unique?
Even with 3 lengths, the trapezium is fixed.
Even with? Can you say?
3 lengths.
Even with 3 lengths, yeah, till that is clear. The trapezium is unique.
Yes.
I was. Oh, why? No, no. That is. Do others agree with that? I don't. I can show you a counterexample. Then you'll be back to the case that we were doing. This is 10. Then you can move this, right? Sorry. No, yes, yeah. It won't go there, but that's not my. I'm not bound to do that.
So you can move the 22 length side, right?
Yes, yeah, that also. I'm basically doing the same thing, but yeah, you can. I'm just moving the top part. It's all the same thing, right? That's correct. Not unique. So no, that's Ishana. That is wrong. Yeah, that is wrong. So that's not the case. But if you take 4 sides, then it is clearly unique, right? Yeah. So if we just yeah, how do I say that? Yeah. So these are some lengths given, and maybe some other length is given A, another length is given B. Then you can fit this in a unique way to make a unique rigid shape. See, my question is this: is this clear that it is unique?
Yes.
Yes, sir.
Right? Calculation wise and not. Is it? Are you using the fact that they are not equal? Ask yourself that. Are you using the fact that 15 and 22 are not equal while saying that it is unique? So now you do the calculations. The calculations will tell you that you have to use the fact that A is not equal to B. Algebra, geometry, all will lead to the same. Nothing will lead you to the wrong place. Let us see. So if A, B is, and this is something interesting. I have not thought about this before. Let me not write unnecessary things. Because I don't want to keep this, it's necessary that they are not equal is what I'm saying. A, B, C, D. Let's assume A is bigger than C. That's again a gift that we have, that any two numbers can be compared, right? So now so now again we do the same thing. And when you go to find the height in the process of doing that calculation, and this is some things which subconsciously you may have already done, already observed. C, and this is X, and that was A, right? So that's A minus C minus X. When you do the calculation, when you do the Pythagoras theorem, you'll be using the fact that they are not equal. Otherwise, it will lead you to a 1 equal to 1 thing, not useful thing. You want this to be useful. You want this equation that you get to be useful. Then A should not be equal to C. Get it? Right? This equation is always true, but it will not give you the X unless A and C are non-equal. Okay? And so needed, right? This is needed. It implies unique. Okay. From the triangle picture also you can see. If you tell me if something is not. Okay. From the triangle picture also you can see. See, the point is that when they are not equal, when the lengths are not equal, then what happens is when you join them, they meet. They meet in very clearly. They meet in the plane with in all sense of rigor. They meet. When the lengths are not equal, they meet. And now you see, because they meet, sort of by similarity and all, also you can see that that trapezium guy is uniquely determined. The calculations in the similarity also tell us the same thing, right? That you can find the height and whatnot, everything. I mean, you can find everything, right? That also tells you. Now here also you can compare. When they are parallel, they don't meet. They meet. If you want to continue the language of meeting, then you have to say they meet at infinity. Infinity is just your new imaginary thing which you have put just to say that, just to continue your language of meeting. Just to be able to use the word meet, you put a point called infinity. Call it infinity, and this you say they meet at infinity. Okay. Now you see the problem is that there is a certain thing about infinity is in a sense infinity is a line. Maybe that I will not try to explain now. And what happens is that they all meet at infinity no matter what other configuration, or no matter if you kind of keep the same information about the side lengths, but they will still never meet, right? Because the other two sides also become parallel, right? That's a fact which also comes from here, because if the other two sides were not parallel, then they will meet and you will get unique. But because you're not getting unique, so the other two sides should also be parallel. Same. Then they also meet at infinity. So in a way, they all meet at the same place, but that place is not a point, it's a line. But that's for a different discussion. There is a fundamental difference here as well. Okay. These are the, let us now pull back. If there are any questions, and now the homework can be, and this can be a very interesting question, is given 4 lengths, use a ruler and compass to construct a trapezium. Okay, so do ruler compass construction of trapezium. Non-equal, obviously. A and C has to be non-equal. We have seen that. Compass construction of so these 4 lengths are given to you. Okay, that's what it means to say do ruler compass construction. The 4 lengths are given to you because you need the 4 lengths. 3 will not do. We have seen 2 will not. This is now the next thing. This is the next thing. We know it's unique, but can you actually make it with a ruler and compass? It doesn't mean you can make it, but you try and see if you can make it. Okay, that's the homework. Let's try it. We will discuss them. I mean, you should tell me, then we'll discuss them. If I forget, you should tell me. All right, let's do some, and let's do the next question. The next question I am not doing because we did this there in that day in the I think so. We're just leaving this question. Okay, let's look at the third one. Is it fine? I'm moving on. Okay, so this is 3. 33, 23, 27, 17. Plus 2 is also there. I don't know where it will be useful. Let's see. So whoever has done it, please. No one has tried this. I have
Sir,
also
I
not.
tried. I
Okay.
couldn't solve.
Okay. 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 From here. You can. I don't know how to do this. Right. Find x. Can you use this? Does this look anything strange? X square plus 1 by x square equal to 1. This looks strange, right? This thing itself looks strange. Have to say something more. See, can x be a real number? Is it possible that this thing is 1? No, it is not possible, right? Okay. So x cannot be a real number. Now, I don't know if they want you to use complex numbers because they've not said anything. Do all of you know complex numbers? Maybe Ishana and Aparna, especially. Do you know complex numbers?
Yes, sir.
Okay. Ishana, do you know complex numbers?
Sir, you mean imaginary numbers?
Yes, imaginary numbers, those kind of things.
Yes.
Right. So let us try. Let us try to use them. But is that in this? I don't know if that is what they want you to do. Now let us think a little bit. Maybe that's not what they want us to do. Z plus 1 is- You see the difference is 10 here, right? 23 and this is also 10. Difference is 10. And so if I take like 20 out, then it doesn't give me anything. $28. If I take 28 out, so I want to take something out so that this, right? No, but is equal to, I will be taking the same thing out of 23 also. and I want this to become negative of this, right? Right, I want to pull out some x from, no, this x is not a good variable. I want to take out some number so that, you know, the numerator becomes something, and sorry, for this it becomes 33 minus n, and this it becomes 23 minus n, and I want the 23 minus n to be negative of that. Okay, so with that in mind, I was doing what I was doing. Yeah, so it's this only. Yeah, it just came naturally. 28. Right. So then if I take 28 out, you see I get x to the 5 plus 1 by x to the 5. Oh, the meeting will, when it ends, says join again. You see, this is what I'm getting. And similarly, I can do here. Get 22 out. Right.